Hello and welcome to today's webinar, a quick glance at GeoCue. We just have a few more people that are joining in, so we're just going to wait about 30 seconds, give everybody a chance to get logged in, and then we'll get going. So thanks for your patience. While we're waiting, a little bit of housekeeping. Group audio is disabled for the webinar. We've got a large group today, so we have disabled the audio, but you can ask questions. There is a question box on your GoToWebinar dialogue where you can ask some questions there, type in your questions as we go through the webinar. We have some Q&A time allocated at the end of the session. Hopefully we'll be able to get to everybody's questions if we don't get to them during the webinar itself. This webinar is scheduled for approximately 60 minutes, and so we'll try and keep to that time. We know everybody's time is valuable, so we don't want to run over. The webinar is being recorded. This is the most common question we get asked at the end of the webinar. Yes, the webinar is being recorded today, and we'll be distributing a link to that recording that you can share with your colleagues or use to rewatch the webinar within a couple of days of the webinar. I do want to do a quick audio check. If you look on your GoToWebinar dialog box, you'll see a raise your hand button on the left-hand panel there. Just go ahead and click that just to verify you are hearing me. Always like to see a lot of hands going up, and I'm seeing that. That's great. If you are having some audio issues or any technical issues, you can try to contact us through the question box. Often that's working even if you're having some audio issues, and we can try to resolve those for you. Okay, good. Looks like we have most people logged in. So let's get going. My name is Martin Flood. I'm one of the presenters for today. I'm a VP of Special Projects here at GeoCue Group. I'm joined today by my colleague, Madeline McNabb. Madeline's our Director of Business Development, and she's going to handle some of the business discussion in the second half of the webinar today. And we'll certainly welcome to take any questions after the webinar. You've got our contact information there. What are we going to cover in this hour? We do have some new customers or people that are new to GeoCue. So I'm going to spend just a few minutes on a little bit of GeoCue history and background, just so you understand the company and where we're coming from. And then I'm going to do basically an overview of our TrueView 3D imaging sensors, our drone payloads. Talk a little bit about the hardware, some of the new models and new sensors we introduced a couple of weeks back at GeoWeek, some of the updates, modifications, and new functions in our software, TrueView Evo, and talk a little bit about guest sensors, in particular the DJI L1, which of course is a very common question we get asked these days. Then Madeline is going to step in and she's going to talk a little bit about the business model, some of the product offerings, product bundles that we have, what's included, what you get for what pricing, training and software and so forth. We decided today, for the purpose of just to limit our time, because we understand your time is valuable, we're not going to do a software demonstration. We often do software demonstrations in our webinars, but they do take up a chunk of the time, and we felt we'd rather focus on providing you with some of the information on the products and the recent changes in the product portfolio. However, we can certainly arrange a workflow demonstration or a software demonstration for you, and often those are a little bit better done one-on-one. Just feel free to reach out to myself or Madeline or any of our sales team and request that. We're always happy to set those up. So a little bit about a company background. We were founded in 2003 by Jim Medlock and Lewis Graham. Some of you who've been in the survey mapping industry for many years, like myself, will know Jim and Lewis. Jim was former CEO of Intergraph for 30 years. Lewis was CEO of ZI Imaging. They got together and decided that they wanted to form GeoCue. And since the beginning, the focus of GeoCue has been on LiDAR, or what today we really talk about point cloud, because there are other sources than LiDAR, of course, and imagery technology, specifically when that is close to the sensor. So we're looking at it from a production survey mapping point of view. That means looking at efficient data processing workflows, effective data management tools and techniques and workflows. More recently, as you can see here on the timeline, starting around 2017 and then on into 2019, we started to get involved with end-to-end drone mapping solutions, leading up to our TrueView product line, which of course is what we're going to talk about today. So in 2019, we released the first full sensor, first payload in that, the TrueView 410. The year after, we introduced our Regal integrations, our 6XX series, and then last year, our TrueView 515 was added to the portfolio mix. Now, of course, businesses are dynamic. Life goes on, things change. So you probably have seen, or hopefully you have seen, that the most recent development for our company, of course, is that just earlier this year, we were acquired by MD Group. So MD Group is a technology company that works in a variety of aerial surveying realms across very diverse industry segments. They're the parent company of Microdrones, which is a brand name you're probably very familiar with if you're in the drone space. So we're really excited about this acquisition. We're really excited about some of the potential it opens up to grow our TrueView brand, to grow GeoCue in some of the business areas we're in, and of course some of the overlap with some of the expertise on both sides of those companies. We do get asked, and so I will stress here that you know, it's a business as usual for GeoCue, for TrueView. It's business as usual for Microdrones. We're owned by the same parent company, MD Group, but we're continuing along as our own businesses. So nothing changes if you're a current GeoCue customer. I know I'm looking at the list here. I see we have some of you on the line here today. You know, your support contacts, your sales contacts, the business, the management contacts you have all stay the same. We're continuing along with our GeoCue business and our TrueView brand. To give you a sense of the business before I hop over and start talking about the TrueView product line, if we look at you know, our customers today, where our business comes from, about 20% of our revenue is still in our very traditional manned LiDAR aerial mobile laser scanning production industry. So on the left there, this is where our core software product, our core software engine LP360 resides. Many of you know us because we are the reseller, the North American reseller for TerraSolid, very common software tool that's used in LiDAR production. We have some data management tools there. Our core GeoCue platform, which is a workflow management platform, is used by most production companies there. And of course, we do a lot of training in that space. On the right-hand side, we do have a small group, but still quite active. It accounts for about 17% of our business, which we really call enterprise solutions. We do some development work here, primarily through contract with Teledyne Brown, related to cloud hosting and data delivery for large data sets. We have a product there called our Sensor Portal. We also have a growing LiDAR data production services group. We've had a great relationship with, for example, U.S. Department of Agriculture doing some LiDAR data modernization, and we're expanding that group to offer other production services. Of course, the core of our business, and this has really grown over the last 5-6 years, as I'm sure many of you have, if you've been involved in drone LiDAR, is drone mapping. Both, of course, the photogrammetric workflows, but also now with the availability of drone LiDAR sensors. So here's where our TrueView brand lives, our TrueView sensors. We have a complete workflow that's built on our core software engine. You know, it's been around for 20 years. We do hardware integration. We are a DJI Enterprise reseller. We also do a lot of consulting and services in this area as well. So that gives you a sense of you know, where our business is today. Our main office is down in Huntsville, Alabama, which is where Madeline is based. We have a new building. I say new, we've been in it about a year now. I guess it'll be a year in the spring. Really nice facility down there. Has all of the facilities we need for properly supporting, testing, calibrating, training flights. It's got a great training space there. When you come down to pick up a system, you can just walk from the training classroom out into our test range. So it's a really nice facility down there in Huntsville, Alabama. We have two remote offices, GeoCue Canada up in Toronto, which is where I'm sitting, where I'm based, and we do have GeoCue Australia, which is a joint venture that's based out of Brisbane, Australia. Okay, so let's talk about TrueView imaging sensors. You know, we talk about 3DIS. That's a term that we use for what we call a 3D imaging sensor. We're really talking about LiDAR and imagery fused together. Having your LiDAR and your camera as a single sensor, we just think that the technology is at the point now that this is just a standard way you should think about collecting elevation and imagery for your projects. Now, of course, it's been a great growth area for us. We feel it's it's a really interesting, exciting, expanding part of the market. But that our success is based on our customer success. So here's a list of some of our customers, some of our TrueView customers who've embraced the brand, who we've worked with over the last few years to get their drone lidar mapping programs up and established. And if you're based in North America, you'll recognize many of the names on here. But we do want to recognize them because we do firmly believe we succeed by making our customers successful. So let's talk about the hardware, specifically some of the new sensor models and some updates we're making to our product portfolio. To put it in context, our goal with our TrueView sensors, our TrueView hardware, from the very beginning, we wanted to have a portfolio, a family or range of sensors that was useful for professional survey and mapping. And we defined that as basically from, say, general purpose topographic mapping, let's say doing a digital terrain model under canopy to do 2-foot or 1-foot contours, to high-end, high-accuracy survey grade sensors for engineering work. An example there might be, transmission line mapping or highway mapping, something like that. But very much we're based in what we call the survey and mapping side of drone lidar. So inspection is an interesting area, but we don't do a lot there. Just straight visualization is interesting, but again, not something that we necessarily do there as well. And you can kind of see some of our design goals here. I'm not going to go through these all. I just want to kind of emphasize, we've built our design philosophy based on the feedback we had from our customers. Having been in the industry for 20 years, many of our customers were starting to look into drone mapping. At the same time, we started looking at payload development. So it was a joint, we listened to the voice of the customer a lot in our designs. We really wanted to have a standard workflow, a seamless end-to-end workflow from hardware through the software product. Obviously want to focus on high quality components so that we're building a survey grade system. And our target really is, when we talk about drone lidar, because that's a very generic term, we're really aiming for what we call mid-range commercial drone deployment. That is, our payloads are in the 2 to 5 kilogram range. They're easily mounted on a lot of commercially available systems. They're not extremely lightweight. And they're not necessarily something you're going to use on a very high-end military drone platform or something like that. But we wanted to focus on that, and of course our reliability, the easy use, the quick learning of the workflow all became important parts of getting people able to use their TrueView systems and up and running quickly. Now I do want to talk a little bit technically because most people that are interested in getting into drone lidar do want to understand the technical part behind it, the lidar part of it, the positioning part of it, and so forth. It's a little bit more, requires a little bit more knowledge than just say, flying a camera as so forth. Although, of course, photogrammetry is an important field as well. But so here's the lidar part, the laser scanner parts that go into our portfolio of products. Our initial offerings were based on the Quanergy on the right there, but these days we're standardized on the two on the left. In the center, the Hesai Pandar, which is part of our 435, 515 models. This is a lidar that comes out of what I call the automotive class of lidars. And if you've been following the industry, if you've been following any of our discussions, this is really lidar development that's being driven by essentially self-driving cars and robotic vision. It's how do we build low weight, low cost, but effective lidar systems for scanning the environment around us. And as mapping people, that's great because we can build off of that, because many of the developments that are going on there are quite useful for building mapping systems. So something where we're actually doing survey work. And the Hesai is definitely in that class. It comes out of that automotive sector, so it has great performance for what it is. But from a lidar perspective, of course, it's not a purpose-built survey mapping lidar. For that, you need to go, for instance, on the left to something like a Regal Minivux. So we've standardized on the Regal family, and the Minivux in particular is an extremely great design for drone mapping. So we've worked with Regal for many years, in traditional lidar, but certainly on the drone lidar side, they've been a great partner for us. And so we've worked with them through all the different variations of the Minivux up to the Minivux 3 now. This is definitely where we think of the high end of our product portfolio. Now, obviously, you can go to even higher end lidar systems on that price performance curve, but this is the core of the TrueView portfolio here. So our current sensor model, so those are the lasers that we build into our sensors. For positioning, we've standardized on a Planix, so we don't offer any other options other than a Planix. We think they're best in class for positioning, so you'll be getting a TrueView sensor with either an APX15 or APX20, and you'll be using pause pack for the positioning. It's become such a standard for us. It's become invisible, like any great technology, right? But we're fully built around the Planix family for the positioning. So when we integrate those with the LiDAR, these are the sensor models that we currently offer. And I'll talk a little bit more about the newer ones. That should read 640 and 650 in there. The Minivux-based systems, which are really the high-end, high-accuracy engineering grade systems. We've had a couple of different models in here because the Minivux itself has changed. It's gone from a 100 to a 200 to a 300 kilohertz system. And I'm going to talk about that a little bit more in the next slide. In the center is our TrueView 515. This is our real workhorse. This is the Hesai-based sensor. It is a really rugged, great general purpose drone LiDAR system that can outperform most of the systems in its class in terms of accuracy, beam quality, ranging performance, and so forth. We've had customers have great success stories with this. And then the TrueView 435 is a lower density sampling system. It's still based on a Hesai Pandar, but it's a lower price point, slightly lower performance model. It's more of an entry-level system if you're just looking to get into drone LiDAR. So I mentioned our Regal models. This, of course, is the high end of the portfolio. The TrueView 645, 650, which we essentially announced or launched a couple of weeks back at GeoWake, are the latest versions on this. If you've been with us a while, and I do see we do have some customers that have been with us for a few years now, this goes back to the 615, 620, 635, 640 model numbers, essentially as the Minivux has changed. However, the 645, 650 is a different update for us. In this case, what we've done is we've designed the system, basically redesigned the system to reduce the mass, reduce the weight. So it's now capable of being mounted on a DJI M300. So essentially reduce the mass, so it's an acceptable payload for an M300. The M300 is a very, very popular platform out there right now. If you put aside the DJI China potential embargo for some customers, but it's a great platform, very popular. But reducing the mass on a payload is great because it just opens it up other sensors, or with your existing sensors, if you're using a Harris platform or a Skyfront or something like that, you're just going to increase your duration of your flights. It's just always better to be lower mass. So that's what we've done with the 645, 650. These are available now. They'll essentially be replacing the 635, 640 in our product portfolio. They're still Minivux 3, still has the dual photogrammetric cameras down there. The main difference is, rather than the dedicated battery pack, we're now powered from the drone. One way to reduce the weight, of course. We've taken the opportunity to upgrade some of the core components. We have a new core compute unit in there that incorporates some changes and improvements to our timing subsystem. But other than that, its performance is very similar to previous 6XX series family. You've got the full 120-degree cross-track field of view, and of course it comes all bundled with the software packages, and Madeline talk a little bit about that. So the 645, 650, that's our latest at the high end. It's available now, and essentially that's going to become our workhorse for the engineering level type customer that needs that highest best-in-class accuracy. Now, I mentioned the 435, which is a new model. This is essentially replacing our TrueView 410. It's also based on the Hesai, but it's the 16-channel version. So it's a lower sampling rate. So of course you get lower point density, less performance in canopy just because your sampling density is lower. But it still has all of the other characteristics of, say, the 515. So you've got the dual cameras. All of our systems are integrated. That's that 3D imaging, that integration of LiDAR and camera. It's just a thing that we do with all of our designs. It's also lightweight enough that it'll work with an M300. That's a very popular platform that it gets used on. One difference, and again, Madeline will talk a little bit more about this in the second half of the webinar, is this system is available via a subscription or our rental program, essentially. Our 6XX, the Regal-based systems, are only available for purchase, but these systems you can rent on a monthly basis. If you just have, certain projects you need to do LiDAR, you're not yet at the point from business where you feel investing in ownership is the right choice for you. One thing to note, we do maintain upgrade paths between our sensors, our same class of sensors. So the 435 is upgradable to the 515, which, as I mentioned, is our core workhorse. So you can't go wrong by starting with a 435 if it's your first drone LiDAR sensor. You want to get into the business, you want to build some client base, you want to get some project experience, and then down the road you realize you do need the performance improvement you get with a 515. There's a very nice upgrade path there. For that, and we really do think this 435 is a great drone for your first drone purchase. We also announced at Geo Week we do have a M300 mount for all our systems, of course. As I mentioned, M300, very popular platform. This works with all of our sensor models, including the new 6XX series with the reduced mass, reduced weight. It does replace the gimbal mount. You do have to be very careful with the M300. The spec on that, the capacity for the payload weight is pretty tight, even for some of DJI sensors. In fact, the L1 is, I think, actually just slightly over what DJI itself specs. So you do have to be careful with that gimbal. We feel our traditional approach to LiDAR has always been you don't necessarily need to gimbal it because you are direct georeferencing through the INS, the Aplanix in our case, and that gives you a very robust solution. But this is available now should you be moving onto the M300 platform. So those are some of the updates on the hardware side. Now, as I mentioned from the beginning, our philosophy is we want to sell you a complete solution. We want to build on our 2 decades of experience on the software side of LiDAR. We have our core engine that's built around our LP360 architecture, and we have that bundled as TrueView Evo. That's the software that comes with your TrueView hardware. And so we're constantly adding updates and functionality and quality of life and new features to that. So I just kind of want to go through a little bit on some of the improvements that we've added there, some of the updates that we've done there. If you're new to TrueView, TrueView Evo is a desktop software. So you install on your desktop, you run on your desktop, but it is part of an ecosystem. As again, we want to have a full ecosystem for you when you're, working with TrueView. So we do have Reckon, which is a web portal that all TrueView owners have access to. You get that set up when you purchase or rent a system. That Reckon web portal then ties into things like calibration tracking for your system, data publishing, hosting, site. There's a bunch of stuff that's related to Reckon, but the actual processing itself is done in Evo on the desktop. After of course the data has been acquired in the field, and that's what drives you to be able to take that great data you collected during your flights and turn it into a deliverable that your customer is going to pay you money for. So a couple of additions we've added into Evo. Metashape, you're probably familiar with that if you've been involved in the photogrammetric side of the business. So from Agisoft, it's a structure for motion package, photogrammetric package for generating ortho photos from your imagery. We've always used Metashape and Pix4D. Pix4D is a great package as well. We have many customers that use it as the solution for generating your ortho photo from your imagery in your TrueView system. But we wanted, the feedback we're getting was we wanted a little bit tighter integration with Metashape. So what we've done is we've integrated the console version of Metashape directly into Evo. So you can launch it from within Evo. You can structure how you want to run that session. You can even pass in your LiDAR digital terrain model, your elevation model for LiDAR, because if you have LiDAR and imagery together, let's use that great LiDAR elevation as the surface for our ortho photo generation. And that really helps with the efficiency and the quality of your ortho. It also adds some other quality of life improvements just based on being directly integrated within the Evo workflow. As part of this, we built a new job processing routine within Evo, so that's now available to run Metashape and Strip-Align, which I'll talk about in a minute. Batch jobs in the background, so you can kick these processes off, because photogrammetric processing obviously usually takes a little bit longer than your point cloud processing. So we have a full job manager, batch manager in there that allows for job queuing and so forth. So Metashape for Evo, MFE as we refer to it, that's available now as a direct add-in for TrueView Evo. It still will work. Evo still works directly with Metashape. If you have a full Metashape license already, you do not need Metashape for Evo. Let me make that clear. But it's a great way to add that orthophoto generation directly into your TrueView workflow if you're not currently using Metashape or Pix4D. And you do get great quality orthos from these systems. Obviously, partly because you're flying so low, but the camera qualities can be quite good. I mean, these are really very, very nice ortho from the drone mapping. So the other add-in that we just released is Strip-Align for Evo, or SAFE as we call it. We're often not too creative with our name, so MFE and SAFE, SAFE. So Strip-Align addresses the problem of what you do when you have a project where you have some dynamic residual error, which essentially is saying that the shifts between your flight lines. How do you do strip matching in that case? Now, as I mentioned, we're a longtime partner or reseller for TerraSolid. There are tools from the traditional airborne industry that let you do that kind of strip matching and so forth. TerraMatch is a very common tool that's used there. But we realized fairly early on that the drone LiDAR mapping community, certainly people who are entering it from the drone or survey side, not necessarily from the engineering or established LiDAR side, TerraMatch and tools like TerraMatch are a bit overpowered for what we need to do with drone LiDAR. They're really powerful packages for doing traditional airborne LiDAR, mobile LiDAR, terrestrial LiDAR. There's a lot of functionality and capability in it, but not necessarily something that a drone LiDAR surveyor using drone LiDAR wants to put into their workflow. So we partnered with Bayes Map Solutions. They're a company that makes a variety of tools for working with LiDAR data. Their Strip-Align is a great tool. We really like the way this works. Uses a slightly different approach, and you can certainly read in some of their technical publications about that, Bayesian mapping. But essentially performs the same function. It will geographically correct and match your strips together, or do your block adjustments if you're collecting over several days. And so we decided to partner with them. We fully integrated that into Evo. The one thing we really like about it is it's really powerful. It doesn't require a lot of user input, so it can be built into our batch job processing system. You really don't need to worry too much about any sort of parameter tweaking or anything like that. You essentially feed in the LAS layers, the flights that you want to strip align, and it will run through and do the block bundle adjust and the strip alignment of those tools, and you get really good results with that. So it's built into that new job batching system. One difference between Strip-Align for Evo and Metashape for Evo. Strip-Align for Evo is available in two models. Again, Madeline will probably talk about this. You can buy a permanent license for it, but it's also available just on a subscription or a metered basis, because we understand when you have a well-calibrated sensor, TrueView sensors tend to keep their calibration really well due to their rigid frame and so forth. Often, you don't always have dynamic errors or residual dynamic errors in your project that you need to worry about. It's always nice to reduce them if you do have them, but it's not necessary all the time. So it may not be something that you're using on every project. So we do have a metered way to access SAFE or Strip-Align for Evo. We also have photogrammetry workflows, specifically around the Phantom 4 RTK and the P1 camera. I want to focus today primarily on the LiDAR, so I'll just leave this slide in there for reference when you get a copy of the video. But we do support some just photogrammetry only workflows through those particular systems. I mentioned some new capabilities in the overall portfolio. So Evo Explorer is a new addition, a desktop software, but it's essentially a free viewer for your Evo data sets. It's something you can distribute to your customers or your clients. You can create Evo packages, Explorer packages in Evo, and distribute those freely to your customers. They can see the point cloud, they can see the imagery, they can do a lot of really nice inspection and work and so forth. It's a viewer package. You can't come in here and do point classification or product generation, but it's a great way to distribute your data. It is a desktop viewer. Reckon I mentioned, there's also a viewing capability now within Reckon. So you can use Reckon not just for managing your sensors and your calibration, but also for publishing, hosting your project sites, map sites as we call them. So you can publish your data up into the cloud. We're hosted in Amazon. And you can do that directly from within Evo. We've added some of the visualization capabilities of Explorer into Reckon, so you can use web visualization as well. That's in beta testing right now. If that's something you're interested in, definitely let us know. We can help you get that set up as a beta tester. So I want to wrap up. I'm just going to spend a couple of minutes talking about guest sensors, and then I'll pass it over to Madeline to talk about the business model and the product offerings that we have and some specifics there, and get into pricing and so forth. But we did want to talk about what we call guest sensors. So these are essentially designated DJI sensors that have we have integrated a workflow into TrueView Evo 4. The three main ones are, of course, the Phantom 4 RTK, that's a pure photogrammetric solution, and then the two dedicated payloads for the M300, the P1, which is a 40 megapixel full frame camera, and of course the L1. I'm going to focus a little bit on the L1 because this is a topic we get asked about a lot. It's a lot of there's a lot of discussion in the industry about the L1, the impact that these lower cost systems, a lot of them based on this LiveVox Avia laser, are having. And we do want to support the L1. I wanted to talk to you a little bit about our philosophy here and where that L1 fits into our product portfolio and the integration within Evo. So I mentioned, the L1 is based on the LiveVox. Many of the other lower cost systems that are out now are also based on the LiveVox. The LiveVox is a great piece of technology, but it's definitely out of that automotive class of LiDAR, as I mentioned. If you're looking at the LiveVox Avia as that's the LiDAR component of your mapping system, what are the pros and cons? Well, it is very low cost. That's partly why you can get these systems at such a lower price point. It's low mass, under 500 grams. That's great. Low power consumption, also great. It has an effective range that we feel is suitable for mapping. I would caution you not to go by some of the ranges you see listed by LiveVox or even DJI, which can be out to like 290 meters to 20% reflectivity and something like that. What we've seen and feedback we've got from users of these type of sensors is, those 200 meter plus ranges are just not achievable for any kind of mapping application. But certainly you can fly these in the 50, 60, 70, 100 meter range, although at 100 meters, you're really pushing it. So it does have an effective range for mapping. It's not the longest range system out there. It'll certainly be outranged by something like a Regal or maybe even a Hesai, but you can use it for mapping from a drone. That's the important thing. It's not something like like the LiDARs in the iPhones are very short range, but this is something that has the range to be used for mapping. It's got a very high pulse rate, and it puts that into a narrow field of view, so it's got a good high density point sampling. But there are some cons with this. This is a lower quality LiDAR system, and I mean lower quality in the sense of the technical performance, not the manufacturing or the system or the company or anything like that. It's just the nature of the technology of the LiDAR, the lasers and the timing that are used. You can get a lot of what we call pulse discrimination errors. That is, the system can have trouble resolving close returns on vertical surfaces. You get a lot of fuzziness in the data. There's much more high horizontal noise than you would expect with a traditional survey grade LiDAR system. And the beam divergence on these systems, and even on like a Hesai class, if you're coming from high performance LiDAR systems, the beam divergence on these systems is very poor from a mapping perspective. For instance, the LiveVox, the L1, the beam divergence crosstrack is 15 times worse than a VUX or Regal VUX or a Teledyne CL class system. I mean, it is a really big fuzzy blob of light that it's putting out, and that can impact a lot of your performance characteristics. And it does have a narrow cross-track field of view. So there are some pros and cons, but you can still have a very decent mapping system as long as you understand the limitations of what you're using. So we do like the L1. It certainly is our recommended entry-level payload. We do recommend a TrueView 35 if you are really serious about LiDAR and you think that you're going to want to eventually move up to something of the class of a 435 or 515. Obviously, that's what we would recommend. But if you are looking for an entry-level system, the L1 is a perfectly good solution. But keep in mind, DJI owns LiveVox, so there's a lot of integrators out there that are using LiveVox and doing their own integrations. It may as well go to the source and stick with the DJI L1. It's a nice out-of-the-box complete system. It does have the gimbal mount. You have to be careful with that, as we mentioned, with other sensors because of the weight limitations. Even the L1 pushes the weight limitations on the gimbal. It uses some additional optical flow techniques, so it does get a little bit better heading, and it's got a good camera and so forth. So there's a good reasons to choose the L1 as your entry-level system. You are going to get fuzzy data with the L1, just as you can get fuzzy data with some of these automotive class LiDARs as well, for a variety of the reasons that, technical reasons. I do think it's important to point out, if you're looking at this from the LiDAR point of view, a lot of these limitations of these classes of LiDAR are on the LiDAR side. All right, they're related to the timing issues, pulse discrimination errors. It's very much a LiDAR issue. So pairing a system like a LiveVox Avia with a higher grade positioning solution isn't going to solve these sort of problems. So you're going to have to deal with these issues, and we do have some tools in Evo that help you with this in terms of denoising the data and so forth. So just before I toss it to Madeline here, the processing workflow we've put in place for the L1 within Evo basically picks up from the output from DJI Terra. So DJI Terra is DJI software that does essentially the proprietary point cloud generation. That's a very standard model for any LiDAR hardware manufacturer. If you buy Regal, if you buy Teledyne, they don't open up that initial essentially geocoding of the data, the reduction of the raw data into a point cloud. It's not open there. It's done in a proprietary software package. DJI is no different. You have to use DJI Terra for that. So we often get asked, can I replace DJI Terra with Evo? You cannot. Evo picks up after you've got your LAS generated, but then it adds the ability to correct some of the processing emissions that are in that. For instance, it adds proper strip line numbering, so you can do strip matching and so forth. It lets you do the geocoding of the images, adds some of the capability to basically run strip align to do better strip matching on the data, and a few other things in there as well. I mentioned we're not doing a software demo today, but we will have a video that covers a full walkthrough of the L1 processing in TrueView, and we'll be releasing that shortly. It's a very common request we get these days, so we feel we'll just have a dedicated video that we can watch people watch so they can see that end-to-end workflow. So with that, I'm gonna just hand it over to Madeline here once she gets ready, and I'll just put up a couple of summary slides here and pass it over to Madeline. If you're ready, Madeline.
Thank you, Martin. Give me just a second. Let me get my screen going. Can you hear me okay?
I can hear you fine.
Sorry, give me just a second.
No worries. Everybody's having a drink.
Alrighty, can you see my screen?
Yes, your screen's up and we're hearing you fine, so you're good to go.
Great. Well, thanks, Martin. So just to cover a couple of things on the business side, so what's included with our TrueView systems and our software. So I'll start with just what's included when you buy a system, whether it's a DJI piece of hardware or our TrueView system. At GeoCue, we understand that our customer success is dependent on several key components. A good portion of our customers have never worked with LiDAR, and there's a bit of a learning curve. Instead of tossing them the hardware and software and wishing them the best, we put a lot of effort into front-end training. We do this by offering our training virtually and on-site each month at our facility in Huntsville. I'll talk a bit about training on the next slide. My advice to companies interested in acquiring a drone hardware system is to put as much emphasis on the software as you do the hardware. The complex part of utilizing drone LiDAR systems is not operating the systems, but it's taking the data collected and turning it into a usable and deliverable. If you do not have existing software tools for working with point clouds, you'll want to make sure that the software you acquire can accomplish the projects you intend to tackle. We've even tried to solve for things most of our customers don't think about, like calibration. Using our customer portal Reckon, we store all calibration information in the cloud. Instead of shipping hardware back and forth to our office to recalibrate, we have our customers fly a flight pattern and we remotely calibrate, eliminating any downtime for the hardware. Support is critical, and I'm biased, but I think we have the best support in the industry. Our team works tirelessly to help our customers solve complex problems. We offer support Monday through Friday, 8 to 5, and because we develop both our hardware and software in tandem, it makes it really easy to identify where missteps or issues may be occurring. Sorry, I'm having a little bit of trouble with my slide deck here. Give me 2 seconds.
Oh, there you
So
go. You're on to your
give
next
me a
slide.
seat.
Yep.
All right, thanks.
Yep.
So training. So as I mentioned, we cover training each month, both virtually as well as on site. So our next session at our facility in Huntsville will be March 16th and 17th. So we break it up into 2 separate days. The first day doing a field portion where we go out and actually collect a data set. Then we spend a half a day processing it on the first day, and then a second full day doing downstream processing, covering things like the automatic classification algorithms, jittering DIMMs, and much more. So what's included when you buy a TrueView system? So of course you get the main sensor unit, which is comprised of the LiDAR sensor itself, and then our dual 20 megapixel mapping cameras, the control box that sits atop the platform that you select, an antenna kit, storage media device, our new external power adapter that allows you to pull power from the drone, one battery with a battery charger, a rugged carrying case, and then of course the 2 days of training. On the software side, which Martin already covered, we include all of our Evo software with each of our systems. So if you get a TrueView subscription system, which I'll cover in a few later slides, you'll get TrueView Evo as well as a Planix Pause Pack. We also include a Planix Pause Pack and Evo with our TrueView 435. And then with our TrueView 515 and our 600 series, we include Evo, Pause Pack, our new Metashape for Evo module, as well as the Strip Align for Evo module. And then Martin touched on this, but of course we include the Evo Explorer, the free viewer license with all of our TrueView cells. In addition, this is a free viewer license. So if you have end clients that maybe don't have LiDAR visualization tools, this is a really nice option to deliver alongside your data. One of the really cool things I think about Explorer is the tool where you can click a point in the point cloud and drive to the 2 camera images associated. It makes really nice work for inspection of the data. So talking about pricing on the TrueView 435, so we offer both the subscription as well as the purchase option. Of course, the subscription includes all the same items as the purchase. You get the software. In fact, with the subscription, you also get a mount for the DJI M300 as well as the M600, training support for the duration of the subscription. For the TrueView 435, our entry-level TrueView system, the 1-month subscription starts at just under $7,000. And the purchase price for the 435 is $55,000. For our TrueView 515, same offering. We have the subscription offering starting at just under $8,000, and then the purchase price of $75,000. As Martin mentioned, the good thing about the 435 is you can easily upgrade that to the 515. So if you're dealing with a fixed budget, which maybe only will permit an initial purchase of 435. If you later decide that you want the increased point density that you'll find with the TrueView 515, you can send the sensor back to us and we can upgrade that, no problem. And then of course on the high end side, our newly released 645, 650, I'm super excited about this. Of course with the M600 being discontinued last year, we reverse engineered the Regal Minibux 3 to allow us to reduce the weight by removing the battery pack and the control box being built into the unit so that we can mount that system to the M300. But then, of course, the reduced weight is just really nice no matter what platform you select. So we're really excited about bringing this to market. So the 645 is priced at $164,000 and the 650 at $199,000. And with our Regal integrated systems, we do not offer the subscription option. So let's talk a bit about software. So Martin mentioned our new workflow that we've introduced for the guest sensors. So I'll just talk a little bit about what's included on that. We're really excited about this. And in fact, I think it's really a value add because let's say you have a TrueView system, but you're also doing photogrammetric mapping. The good news is the software that you get included with the TrueView system also includes all of the tools that you'll need to post-process the data from the guest sensors. So our guest sensor software supports the Phantom 4 RTK, the DJI P1, as well as the DJI L1. For a seat of Evo, it's $2,500, and then you have the option to add on the Metashape for Evo or Strip-Align for Evo, and those are $2,500 each. And then the good news is if you just want to do Strip-Align on a project-by-project basis, you can opt to run that on a project-by-project basis and pay by project as opposed to buying the $2,500 module. So what's the value of having Evo for these guest sensors? So if you're processing data from the photogrammetric system, it gives you the ability to virtually manage all of your calibration data and write directly to the EXIF tags, process in PPK mode using any L1, L2 base station, so you don't have to use the DJI L1 base station, automatically gather and download ephemeris files, update your EXIF tags, and create photo packages that will feed directly into Metashape, Pix4D, or Context Capture. And then, of course, Martin touched on this, but if you're using the DJI L1, you'll still use Terra to process your trajectories, but then going into Evo, it gives you the ability to update the LAS form from 1.2 to 1.4. You can manage your coordinate systems, add ground controls, add ground control points for data QC, do strip align using our SAFE add-on, smoothing tools, and repair distortion that from the imagery collected from the L1. And then in addition, of course, all of our Evo software has all of the tools that have been available in our LP360 advanced software. So you'll have the ability to do downstream processing such as advanced classification, volumetric tools, so you can do things like automatically calculate the stockpile tows, remove overhead conveyors. So those tools are really nice. Generate digital elevation models, do cross sections. We're adding a lot of tools for doing transmission line modeling. Right now we have the ability to automatically extract catenary curves. And then this is of course pretty important, but preparing data for CAD. So obviously a lot of CAD users and ingesting this data can be quite dense for CAD applications. So we have the ability to reduce the data size in our software so that it ingests just a bit easier into CAD applications. So Martin, that was pretty quick on my side. I guess I'll toss it back to you maybe for a couple of questions.
Sure. All right, thanks, Madeline. Yeah, so if you have any questions, I've got a couple here, but do feel free to enter them in that Q&A box, and we'll just wrap up with some Q&A sessions here, and Madeline and I will stay on as long as we need to for that. As I did mention at the beginning, we have been recording this session, so you will get a link to the recording, so you'll be able to share that with colleagues or review any of the sections you want. So a couple of questions here. So one question about do you need the Metashape or Pix4D license for use in Evo or subscription for use in Evo? Yeah, let me explain that. So if you have a Metashape license, you already have a Metashape, a full Metashape license, you can use that. You do not need Metashape for Evo. Metashape for Evo is principally if you don't want to purchase a full Metashape license. The workflow is identical, it's seamless, that's just the way that it has been structured. With Pix4D, plus actually any similar kind of photogrammetry package, you can still work with the imagery from your TrueView system. You can do all of the positioning, all of the geotagging in that, and then the way the workflow works is that you have the ability to export what we call a photo package Evo understands how to build that photo package for import into Pix4D, so you can actually import it in the Pix4D, a Pix4D package, and then you import that package into your Pix4D session. So Pix4D, you do run in a separate session, as opposed to with Metashape, we're more tightly integrated, but it works quite the same for that. So you do need a Pix4D license or a Metashape license or a Metashape for Evo license to generate the ortho photo. So hopefully that kind of clarifies what that question is. Someone was asking about flight times. Obviously, it varies a lot on platforms. You have a lot of options for platforms out there right now, but this people have been asking about the M300 particularly. So with, let's take this 645, this 650, which is the Regal-based 6XX series, the heaviest in the current portfolio, you're going to get 20 to 25 minutes of flight time with a bit of a safety margin there. Of course, it depends a little bit on environmental conditions, wind, and so forth. But yeah, that's typically, our payloads are in the range of 2 to 2.5 kilograms, a little bit heavier for some of the older models. So if you look at that for some of the current platforms that are out there, say the M300, you're going to get in that 20-minute range. Now, there's no reason you can't move to a longer duration, heavier lift platform and get longer longer duration flights out there. We're already starting to see people that are interested in looking at beyond visual line of sight, looking at long duration flights, long being a relative term, but in the context of 60, 120, 180 minutes, that kind of thing. We've got a question here. I'm not sure. Are we using the GNSS from the M300 RTK, and if so, would another platform cost more? Okay, all right. I think I understand here. So uh, all of our TrueView solutions are post-process kinematic, PPK. So we don't support an RTK mode within Evo. You can do RTK solutions. For instance, the L1 will give you an RTK solution, as will the Phantom 4 and the P1. So you can do that natively in the DJI processing software, or whatever the vendor is, its software. So we focus on PPK solutions. Again, built in through a Planix. That can either be through, of course, running a local base station, which is the recommended, most common used, but we also support within Evo using some subscription positioning services through Trimble, of course, Smart Base, and PPRTX for global positioning as well. So we're a PPK solution. Someone is asking, are there solutions for improved scanning speed for high resolution mapping? So if I'm understanding the correction, someone's asking about, can you improve the scanning speed to get higher resolution? So the laser scanners that we're using in our TrueView sensors typically have a fixed scan speed. With the Regal, you can adjust it, but generally they're scanning at the highest sampling rate that they can. That's part of the system. Now these are still sampling at relative high densities. So for instance, the Pandar, the 32 channel Pandar, you've got 640 kilohertz. So you're getting sampling densities of the 100, 200 plus points per square meter, depending on altitude. So you are sampling at quite a high rate, but generally the actual sampling rate or scan rate is not adjustable. It's fixed for the particular sensor that you're using. Okay. So yeah, if there's any more questions, send them in here. I'm just checking here. Someone's asking about ArcGIS sitemap. We aren't directly integrated with any Esri software. Our LP360 engine certainly was originally released and still does support running as an add-in for ArcMap, but TrueView Evo and everything we've been discussing here today is all standalone desktop software. So we don't integrate in any way with sitemap or any of the other ARC products out there. People are asking about distributors and sales. Do contact us. As I mentioned, we have GeoCue Canada, where I'm based. We have GeoCue Australia, obviously GeoCue down in the US. We do have some resellers and reps around the world. What I would suggest is, if you're not based in North America or Australia or Canada, just reach out to us, reach out to Madeline, and let us know where you're located and who's the local reseller that you can contact, or we can work with you directly. These systems are easy to sell and ship from the US around the world. There's no restricted technology in them, so they're very easy to handle. So if you do have some interest and you're outside of North America, Australia, or Canada, don't hesitate to contact us. We can get you set up with that. Here's a very good question. This is a really good question, just potentially from a surveyor. So the automatic ground classification in Evo, and the question that's asked is it robust or is it just for visualization? Which is an interesting way to ask the question. But ground classification is a really important thing to talk about. Obviously, when you're going out and you're doing a drone LiDAR mission or even a photogrammetric mission, often the terrain is the primary thing you're interested in. You're trying to get a digital terrain model, you're trying to do contour mapping, we're doing topo work. That's not all the applications, that's not all the industries. Obviously, there's people are very interested in above ground features for a variety of applications, but getting a bare earth surface or a good ground model is often a key priority for anybody doing this kind of mapping. So we do have tools in Evo that are built on, again, very established tools and algorithms for doing a bare earth classification or a ground classification from point data. So these are the tools that have been used for 20 plus years by the traditional LiDAR industry, people who are going out doing county and state mapping, and they do transfer quite well to drone LiDAR. There are some things you need to be aware of. You do need to optimize things different way. You're working with much denser and sometimes much noisier data, but you can essentially use those same types of algorithms. For instance, an adaptive tin is the particular one that we use in Evo, to do a very robust ground classification. They're not typically, a magic bullet. It's not 100%. You often will have to do a little bit of cleanup. You want to do a little bit of QA/QC, some manual cleanup of the data from the algorithm, just as you would with any LiDAR system. But you do get quite a rigorous ground model with a pretty high resolution given the sampling density. So they're not really just for visualization. You can generate contour maps off these. You can do survey work off these within the accuracy spec of the system, which is going to be somewhere in the 1 to 2 inch, 3 to 5 centimeter absolute vertical accuracy range. So they are robust in that sense. Okay, I think that seems to be it for the questions so far. I think we've gotten to most of these. Just checking here, yeah. Okay. All right, so with that, we're going to wrap up a few minutes early, give you a couple of minutes back in your day. Thank you very much for attending. As I've mentioned a couple of times, we are recording this. You'll get a link to that, so feel free to share that with colleagues. Both Madeline and I are happy to answer any questions that you might have. Please do contact us if you have any interest at all in anything we've shown you here today. I especially want to say to someone, if you're thinking about getting into this industry, if they're thinking about getting into the drone LiDAR, the side of survey and mapping, but you're not quite sure, we'd still love to talk to you. We've helped a lot of people determine, the best way to proceed forward, to the best kind of systems and services to deploy, and sometimes the best decision is not to deploy. This is a really exciting growth business, but it has to be right for you, and we want to help you do that because, as I mentioned on our customer appreciation slide, our customer success is our success. So with that, I'm going to end off here, and thanks for attending today.
Thank you.